Alright, so we're gonna try the last scenario number 5. I call it exaggerated scenario because the amount of unnecessary text and explanations over here is much more than the previous scenarios. As you can see, for example, before like digging into the technical connections and explanations, we have this phrase as the network architecture is designed to facilitate the efficient communication between multiple network segments, blah blah blah. And at the end of the explanations, we have that the network functionality relies on the careful configuration of the IP addresses and static route, blah blah blah. So it's like kind of like unnecessary explanations which added to this scenario. But anyhow, this is going to explain the same network topology that we had, those three routers, R1, R2, R3, two networks, and the static route from R1 to R3 and R3 to R1. So nothing has been changed, but the storytelling and English explanations over here. So this scenario is going to be challenging for our system because of these extra informations, as well as we are missing the explanation of static route over here. If we read this, we will notice that we don't really explain how the static route need to be connected. So it's like just this ensures that the data packets are routed efficiently, the devices are connected. So we are purposely kind of removing the specific static route configuration in order to see how the system is going to react. Before digging to the technical, we just make sure that the server and simulations are ready. We go ahead and run the code. So this scenario is actually to challenge the system's scalability and understanding about like the different type of scenarios, or if you're missing any key information, how it is going to react to it. Let's say we are just copying this and pasting it over here. Let's see what is happening. Even I am curious that how it is going to react to this scenario. Oh, interesting. So it has populated the key value pairs and structured command strings. As you can see, it kind of like ignored the first line, that it was kind of unnecessary explanation, but it kind of extracted the technical terms and everything is correct. But because the static route information is missing, it says, could you please provide the static route details appropriately for the configuration between the routers. So it understood that we are missing some key information, so it asked us to kind of edit that. So let's edit it and then see how it reacts to it. I'm gonna paste the same thing, but I'm gonna remove the last line. So the last line is I'm just gonna remove all this unnecessary thing, but instead of this, I'm gonna add what it is looking for, which is the static route is configured from R1 to R3 through the R2, and static route from R3 to R1 through R2. Actually, we don't need this static route here. once we mentioned, so the static route is configured. So we have added what it was asking us to provide to the system. Let's see how it reacts to it right now. We're challenging the system, so perfect. It could have, you see, as long as we are feeding to the system whatever it needs to know, so it doesn't matter how we are telling the story, the explanation is different, it doesn't really matter as long as it just gets its key value information. So it asks us about the details of static route, we provided to the system, and it worked. So once again, everything is populated here as we are expecting. R1, R2, R3 terminals are here. Let's go and take a look at command strings. I'm curious to know if everything is as expected. So device 1 is 0/0, IP address is correct. 0/0 is to correct, and R3 0/0 is to perfect, and yeah, even the static route is there. So we can see our don't forget that we are on that 90 seconds wait, so we just wait for the image to boot up completely. We're just taking a look at this key value pairs. Everything is green. Yeah, perfect. L3 configuration is populated this time. Previous time it was empty because it couldn't detect a static route. R2, both of the interfaces are there. We don't need it. It doesn't need that. It's a bridging device. Perfect. All good. Here we go, and these are the connections. Okay, so I think we're almost done for waiting. Yeah, this is time to telnet to device 1. We're in R1. You can see on the right side of the screen. Once the wait is over, the wait is 15 seconds, so we're gonna start basic configurations. That was kind of good that we had this example of having a non-working scenario, then how we can deal with it. So it was asking for some specific information and we just provided to it. Yeah, basic configuration is done. Hostname interfaces, L3 static route is configured from R1 to R3, as you can see here. Telnet to device 2 is initiated. Let's go to device 2. R2, you can see the terminal. So basically this is good to know that the system is understanding about the missing part of the scenario, that when you are providing some scenario to it, it understands what part of it is missing and it asks for it. So it is not assuming anything, or it doesn't have any default values for that. That's another strength point of it. Yeah, so device 2, basic configurations, that's the only neat thing that we need to configure in this device. 2 interfaces, /0/0 and 0/1 for 2 different networks. It is configured, completed. Telnet to device 3 is initiated. Let's go to device 3. R3, we can see that. Alright. So we are expecting the basic config to be started. Here we go, enable conft. Alright, hostname and interfaces are configured, static route is configured. Now we are testing the system using a ping to R1 interface. Boom, here we go, good. 3 successful packets out of 5, and that's only because of the address resolution protocol. Our table is populated, so we can get full success rate. We do ping from R1 to R3. The first packet might be lost because the ARP table is not populated yet, and boom, here we go. And that was all about it. Scenario number 5 was also tested, and we also have learned how to deal with the scenario that is not working. Thank you.